A departure from the norm. Colin Hickey from Sky Futures tells us all about inspections using their Expanse software. Hi there, Colin. So what am I looking at in front of me now? What am I seeing?
Hi there, Gary. Yeah, so this is the home page of our inspection software, Expanse, and it's a piece of software that's been built out of effectively a managed service business doing drone-based industrial inspections.
And what's your key jobs there? And I think you're UK based, somewhere near Heathrow, I believe. And what's been your bread and butter work over the years there?
Yeah, so we've been going about 5 or 6 years now, and in the past it kind of came from some military guys and a commercial aviation captain who started a drone inspection business, and they focused on one technology in one market, and that was oil and gas. But that's grown over the years into a range of different things. So we've done a different infrastructure, so electrical, bridges, buildings, wind turbines, things like that, and we've spread out to the US, Middle East, Southeast Asia. As well for our offices.
So if I've got, say, a Phantom 4 professional, how is this going to help me? What's this going to do for me?
Right, well, yeah, so we've built this based on doing drone-based inspections ourselves, and there is inspection software out there already, but drones actually change the way the inspection gets done because they're now a lot more visual. So you've got these like flying robots that are capturing lots of video and pictures and thermal imagery, and then also a lot of telemetry data and things like that, and we're working towards bringing the best out of those devices. So the idea being, very simply, when you land your drone, you don't have this problem of filling up an SD card with tens of gigabytes of video and then wondering what to do with it, and then effectively just decimating the value of all of that information by just creating a report in a desktop publishing tool, which is typically what people do. So with this application, you can very quickly and efficiently, and more efficiently than even using a word processing tool, produce a really high quality report in a fraction of the time it would have taken.
Okay, can you run us through something like that then? What do you mean? Perhaps you can show me what you mean.
Okay, so I've got a staging server up in there just so that I can kind of build a report with you, but I'll show you the output first actually. So if I log into the actual production environment, so I'm logged in as myself here, and I'm an inspector for Sky Futures, and one of the companies that I look after is this anonymous oil and gas PLC. So this is kind of anonymized data that I can show you in amongst the clients in there. So if I just show you the output, if I click on this asset here, right, so this is what I would deliver to my client. So this is where, as an inspector, I come in and manage a bunch of different projects that I do on a range of different facilities around the world, and my client gets this same view. So when they log in, they can see all the work that I've done for them over time.
So we're going to see how you adjust it now, or are we going to see what the end user sees?
I'll show you what the end user sees first of all, and then I'll build up to how we got to that. So they'll click on their facility, they click view, and we do this thing in Expanse where, rather than thinking from an inspection project perspective, we think from the perspective of all the information that's been captured for asset integrity for inspection, because really the inspection project is just a kind of a necessary evil that you need to do to try and ensure asset integrity, and drones actually change that, because it won't be too many years off in the future where a drone will just set off from a docking station, fly around, collect a load of data, land, and that data will be somehow analysed, whether that's manual or automatic or whatever, and there's lots of people working on all aspects of that value chain there. But the process of inspection will actually change quite a lot, and all you're going to be left with is a flying robot and some web services that do something with the data. And what we believe is this is the beginning of that. So this is what you get. You deliver to the client a report, but it doesn't look like a typical report. You started on a map, you click once on a problem that's red and angry and kind of shouting at you a little bit, and it takes you to that problem, and that's it.
Now you've got that base model that's behind it. How's that arrived on the screen?
So
oil rig,
we've built the 3D environment in a kind of versatile way where this can come from point cloud software. So if you do, if your client gives you the time and space to do the flights necessary to capture point cloud generation 3D models, then you can do that. That doesn't work too well on vertical structures, we find. So kind of we're kind of waiting for airborne LiDAR pretty much to solve that problem. If you're doing survey on buildings and things, then it's better. But the idea is that this model is really just to give you the gist of where things are, where problems are, and to take you to the issue. So it can come from either, if you have a CAE system, so if you're using some kind of CAD environment that has a 3D model, then it can export a format that can be read by this. Or actually on a lot of the jobs that we do, because we're working on old infrastructure, we get plan and elevation drawings, and then a draftsman builds a 3D model in the space of about a day. So it's the cost of a few $100s, and we spread that cost over several projects going into the future. And you can use pretty low res 3D models actually for a lot of the stuff. Like if you're just doing a simple building, then a rectangle will do. But it really, the amount that it helps you contextualize your findings is pretty powerful.
Yes. Gives you a "you are here" sort of a thing. You'll instantly, if you know the infrastructure, you'll know where that bit is on site, won't you?
Exactly.
So how do these things get flagged up as red then?
So that is the traditional inspection process. So we've built a piece of software which gives somebody the ability to upload all their media off the drone and then go through like they would have done and say, right, this picture is evidence of problem 1, this picture is evidence of problem 2, and just go through their media and do the inspection process the way that it has been done traditionally, effectively. So we're kind of,
sorry, Colin, have I jumped ahead then there? So has somebody gone through, tagged the images, and to the end user they're seeing this 3D model with the problems that somebody has physically gone through and seen?
Yes. Yeah.
Okay. Yeah. Right.
And I can take you through that. It's pretty slick. So the idea being, if I just go back to this kind of staging environment, if I go to reports and say that I want to make a new report. So let's say I've just landed my Phantom 4. I can say, right, I'm going to do a job for Future Core, for example. I'm going to do it on a facility called Bridge, something like that. I can then say, right, so that bridge may be comprised of several structures. I'm going to make a new structure on it, call it like entire bridge, because I'm not going to do any particular tower or whatever it is. Click Save. And then if I lock that, I can then upload some media. So I very simply just kind of take some pictures off the SD card, yeah. Drag and drop them into the browser, and I get a picture uploaded, just very nice and simply. And it does a little bit of work on that picture, so it kind of makes a thumbnail and gives it gives it references in a database and does all that stuff as you'd expect in a tool which is helping you organize all the information. So that's done, that's ready. So it's refreshed the page, and I've now got this ability to screen all of my raw media from the stuff that I'm going to use on this job, right? And that's really subtle. So maybe I'll come back to that in a bit. But so there you go. So I'm going to use that one picture on this job, and I come through to analyze observation, and maybe something was spotted in this picture. And really, if you were taking a day over writing an inspection report, this would be 60 or 70 images and some video clips and things like that. And you've got a bunch of tools basically in the browser, so you can annotate the image and say, I've found a particular problem here on the structure. You can edit the properties of things. You can crop the image, adjust brightness and contrast, and then the key thing is you assign this as evidence to an observation. So you can say, maybe crack detected, something like that, and you select an observation of a particular type. So you manage this list. So all of our clients who use this have their own version of this list that they manage. So for wind turbine guys, it's a different list from electrical infrastructure guys, and then they say maybe north tower, west side, outer wall, something like that. This is all made up nonsense, but you kind of see the point. And you give a description of hairline crack detected, and it's not really a supporting image of that. I'm just putting in something sufficiently anonymous to show client data, and then you say what it is. So that's you might say that's high severity, and then you create a link. And what you're doing, you're just kind of working your way through this gallery of media you've uploaded, which will be an image, some videos, maybe even 360 video that plays in a nice 360 player here in the window, and you're building this list down here.
And then how's that magicking itself onto, I guess you've got a 3D model of the bridge, so how's this appearing on the bridge?
Let me find a nice drawing of a bridge. There's one, yeah. So upload, schematic, and right, there's one. So I'll save that red arrow. So okay, so I'm uploading another type of media now, which is of image type schematic, and it's just getting uploaded and handled by the server, so a little thumbnails being made and stuff like that. And what is traditional in an inspection report is that you you give the context of all of the problems that you found on a photograph or on a CAD drawing of some sort, whether it's a bridge or a wind turbine or whatever. You say spatially where these things are, and that's a fairly typical way. I think I messed that up there by clicking save while I was uploading. Let me just try that again. It's a fairly typical way of contextualizing your findings, right? So let's say that I've made an anomaly, an observation there called crack detected, as you saw me do. So here with this other type of media called a schematic, this is a very traditional way of doing it. So you would say, right, I'm going to link that to an observation, and there on that north side west face, I click it and I say crack detected is there. Yeah. And that's, that's fairly typical, right? And then I click save and that's done. Now, your actual question was, how do I do that in 3D, right? And this is a total no-brainer, right? Everyone can understand how that works, and in 3D, it's no different. So I click on that. I've got a 3D model that I've had a draftsman make, or I've got from a CAD system or something like that, and I double-click on the surface of the 3D model. I zoom in. I pick the bit where the problem is, which was about there, and I try and actually, if I just scroll down and look at the thumbnail, I can kind of like line the two views up. So you can see I'm looking at this thumbnail here, and I've got the 3D environment, and it's about there, and I just do exactly what I did before, which is link it to crack detected. And when I click link, it's done. Yeah.
That's what I was wondering, if that image would be dragged into the 3D model in roughly the right place, and then you would sort of tidy it up a little bit. So once I've got this, so this is whatever today is, January the 5th or whatever, if I go back on January the 5th next year and do the same thing, and so on and so forth over time, can I run an animation that would allow me to see the problems moving up and down the infrastructure?
You kind of can. We haven't, so you can kind of see here, if I go back to the kind of the full production system that's got this demo account in, you can see we have filters on the left hand side, and that's exactly why we built the system the way we have. So, a traditional view of, it's a good question, right, because a traditional view of inspections is to see a list of reports like this, right? You've got hundreds of reports that sit in a stack. And by having an asset-centric view of the world, as we've got here, then you can use all these filters on the left-hand side. And you saw me build an observation earlier, right, where I said it was a crack, right, or it was corrosion, or whatever, and I can filter by those things and apply them, and then see those. Now, other properties of these things are time, as you rightly point out. So I only have 2016 stuff here, but we have some clients where data goes back to 2012 with drones, so they were kind of fairly early adopters. So we've got 2012, 13, 14, 15, 16. So we've got half a decade of data, and they can just play with the filters down the left-hand side and start watching things change and move with time, which is the beginnings of pretty powerful analysis to start to see things happening. And once you start to be able to put points on a graph, you can then draw a line through it and start to make predictions, right?
Yeah, absolutely. No, I can see that instantly being an advantage of having this. Well, I guess one of the huge advantages, it's just like Google Earth. Google have been very, very clever teaching people how to use a GIS tool, because everybody wants to see their house from above. But you only need to then, you've trained millions of people to do that, and if you then send them a KML of something work-wise, they can instantly see it as well. They know how to do it, and we intuitively work in 3D, don't we? We're not really 2D beasts.
Yeah, that's
so
right.
I can see that being quite a powerful thing.
Exactly. And your question actually is very good, because your question is about how do I see this in 4D? So how do you see my 3D model through time? And that's something that sequential inspection reports don't give you. And that's what this is. That's what drones really enable. It's this, continuous, just non-invasive view on your asset without need for shutdown or whatever it is, whether it's your bridge or your wind turbine or whatever. You can just kind of look at things and see it often with low cost and little impact, which is very different from the traditional way of doing it.
And would you command your unmanned aircraft, because if that one photo you had there is obviously the right place to catch whatever that fault was, so you would want to be taking that photo from exactly the same place again, if you could, further down the line. Do you go the other way and tell it, now go to this place, this place, this place? Because eventually you'd find a way of flying around your infrastructure that was best for the survey, I would have thought.
Yeah, well, that actually, yeah, that gets into the realms of our kind of an internal R&D that we're doing. So this piece of software here that we use for producing inspection reports is something we've used ourselves internally for 12 months, and we now sell it commercially to other inspection companies. So, you know, effectively cannibalizing our own business, right? Because we believe the future of the drone business is in the data, not in the
Yeah,
flying,
yeah,
you know, and
yeah, yeah.
part of what we're working on now, our R&D team are working on things that try and solve the problems that you highlight, and not all of it exactly relates to exactly where the drone was. So like one of the things we've worked on, for example, is a tool called fingerprinting, whereby I can select a picture and then say go and find me other instances of that item throughout time, whether it's from the data I've just uploaded or whether it's from stuff 4 or 5 years ago. And you
Right.
don't actually, it's pretty, with our image analysis tools, it's somewhat tolerant to kind of geometric distortion, so you don't actually have to be in exactly the same spot. So it depends exactly where you try to, you know, if you focus on the problem you're trying to solve rather than the technology in your hand, the drone's GPS and, you know, its exact location spatially within a tight, complex geometry is not actually the only way that you need to solve this problem. You can do it within the final picture that comes out as well.
Sure. Yeah, but obviously they're getting smarter fast now, and they're going to not fly themselves into the
Yes.
into the infrastructure, and they're going to be able to fly themselves very accurately around an infrastructure based on vision as well, because GPS is rather inaccurate.
Yeah, that's right. Yeah.
Exciting times. Well, what else can you tell me about this? The thing is, I have no idea what a grown-up inspector would really be wanting to see in his life. What's the most compelling point to a traditional inspector for this? Forget the drones, forget the technology. How does it make his day easy?
I think one part, well, I can give you kind of a list of things that our own inspectors benefit from, and that is just, you know, systematically around the world we get consistent reports out because we're using one common system. And that's one. So even if you're just using photographs you've taken yourself, because as you can imagine when you're looking at this doesn't have to be drone data. This could be stuff inside
Sure.
a ship, taken by hand, right? But if you can spatially locate these pictures straight away with comments about the problem that you've identified, that's fantastic. There's no clear way of doing that. People are filling servers with 100 megabyte PDF files, so that lightens the load massively. The other thing is, the traditional methods. There are no good tools for handling media, particularly. If I go to this company, if I go to anonymous oil and gas company and go and find a draft report that's open, I'll show you in the step 2 here that we were working in earlier when I was building the report. If I choose a video file, when we're working videos, there's a bunch of tools in here for like kind of cutting the video, right? So I can cut the timeline down from 7 minutes down to something else. I can take frame snapshots out. I can add voiceover to the video. I can add textual captions for a period of time. So if I click caption, I can say, "Hello, Gary," and like put this, put this where I want in space and in time on the timeline. And it's things like that are like, that would take an annoying array of third-party tools, but for the inspection engineer, he logs into this and it's all there.
Yeah, I get it. And so this is all part of the. Can you do a fly around of the oil rig from this, or whatever the infrastructure is? Can you fly around the problems and stop and start, or is that a little too far on?
Actually, I did see that on one of my colleagues' machines the other day. It's not in the product yet, but yeah, we're getting there with that. It's we're building up from. We like to think that we're coming from the real world of selling into the existing incumbent inspection market rather than starting off in the world of academia and working backwards, because it means we can bootstrap the business and actually generate revenue for something that is good today. So, but some of the R&D stuff we're working on in the future, which is perhaps a good reason for another chat like this in the future. I'd love to show you all that stuff that we're working on. Some of it is real Harry Potter magic.
Have you got to run into a wall at a train station?
Yeah. I can actually, I'll show you one of them. I'll show you one of them that's in here that's really exciting. Okay. So there's this tool called Corrosion Analysis, and it relies on some other things happening, right? So what I can do here in my image analysis tools, right? So this is just a page I was on before. So I'm building a list of anomalies, but I want to add a bit more value to this particular image. So I go to my corrosion tool and I mark up what I think is corrosion. Now, at the moment, that's where we're at with it. I actually have in our test environment, I've got a version of this algorithm which suggests to me where the corrosion is, because of course every time somebody does this, we're learning from it to try and work out, get the computer to say what is corrosion and what isn't.
Look at that.
Yeah, and I hadn't scaled the image, so it's not right, but you know, you get the point pretty clearly, right?
Yeah. And what would those different colours mean? The depth of the corrosion, or a guess of it?
No, not yet. Yeah, so we're working on trying to work out, because of the image properties like blistering and texture and colour difference and things like that, we'll be able to distinguish between different types of corrosion, but that's going to take a lot of classification. Right now, the colour is just to distinguish boundary edges where we feel that there's a difference. But we don't want to infer yet what that difference is. We're still kind of learning. Right. We're still learning about that.
That's pretty groovy. Why didn't it get the bit at the bottom underneath? Did you not click that?
Because I think actually, yeah, it's really interesting. You see, there's some kind of blistering here. It's very hard to see probably in the screen recording. Yeah. So there was a change, and it didn't in the method we used to expand and find all the edges of where we seeded. There was a significant difference. So it's basically your former point, which is, can it tell the difference between types? It can, but we just don't know what to infer from that yet. So I would have to seed down here this little map of Spain and get that seeded and started as well. But then I would just, you know, and that's the way we built it, basically, to repeat the selection. So every time somebody does that, of course, we're logging it, and we're trying to classify to get better and better. And like I said, in our QA environment now, I load that image and it tells me where it thinks the corrosion is rather than vice versa.
It's very interesting. I know a lot of the other cloud providers for mapping, shall we say it that way, are most definitely using their user data to improve their products, and that's why they're improving at the rates that they are, really. And it seems like you guys are on the same sort of thing. Now, again, I'm a layman, I'm not an inspector, so you see that shackle on the right hand side. Could you sort of add that to an inventory or something like that, so that you know on this oil rig there's one over there? Because you might want to look at that over time, mightn't you? Because I noticed that straight away I want to put that the other way up, so that if it unscrewed, it wouldn't fall out. But anyway,
that makes sense. I think one of the issues we've got with inspection is it's an old business. You know, it's been going on for a really long time, and there are already existing tools that businesses have got that often they've invested millions in over the years, and drones are not really well positioned to come in and completely disrupt that whole thing. They need to complement it and kind of help it evolve rather than try and cause revolution, because I think they're going to hit too much of a brick wall. So the way that we built this system is that it's, you know, as you can see, everything I'm doing here is in a web browser, and it's all been built with web APIs, which mean that it can talk to whatever your asset integrity system is already. So if you have a tag ID for this, you know, these kind of fixing cables and fixing bolt and things like that, then it will pre-populate into here. The idea being that when I'm working on an image of something, I can and I assign its properties, I can say what. Say edit, I can say what type of item it is, and I can actually, that will be a link to your existing 30-year-old asset integrity system for your bridge or your ship or whatever it is that you're trying to keep running.
Yeah, it's interesting that you mentioned resistance from the older industry. My brother restores buildings for people like the National Trust, and I have a degree of resistance to any drone-based stuff from him, because his point of reference is, can it beat a man in a bucket? That's he'll swing blokes around a roof in a bucket under a crane, and of course then you've got your real inspector with your 30 or 40 years of experience seeing stuff straight away. So there's, just as an aside, that's his point of reference. To impress my brother, it's got to beat a man in a bucket, and I think we're probably getting to that point now.
Yeah, I think we are. I mean, the man would, you know, he, instead of being in his bucket, he could be working wherever, getting the data uploaded automatically by a drone, making decisions that he can go back to a point and say, let me just look at that again. You know, something that you can't do unless you're going to go out to site with a bucket, that you maybe get the opportunity to do that once every 2-3 years. So it's you know, it's cheaper, it's safer. It's, you know, the reasons are great. So I totally understand your brother's point, because it's and it's actually beneficial to us in the drone business as well, because drones are not going to be perfect yet. You know, we need to prove that they're right before they'll be broadly adopted as, you know, the standard.
I suppose you've led me into asking, do you stand by your data then? How confident are you in your work? Oh, you've got to say you're very confident, haven't you? But
well, it's
obviously you've got some integrity.
Yeah, the guys actually putting the reports into our system are qualified inspection engineers, and that ultimately they sign off the report, and they are they are certified to produce inspection reports, and they wouldn't we do talk about the image quality coming out. If I scroll up here, I've had debates with them about should I make this. You can view the report here on a web page, right, and watch videos and stuff, the kinds of things that you can't do offline, but equally you can download a PDF report, and because we are selling into an existing industry, you don't get your invoice paid until you deliver that PDF report, regardless of whether it's on this website or not, right? The quality of the images in that PDF report are currently what marks a job as complete or not. So those guys won't they won't release that report to the client. I can say, well, I'll save you 50% of the data size by making it web quality, and we don't actually. We make it full original image quality because it has to be high enough quality for the job to get signed off. So this really comes from solving the real world problem of certified inspection engineers producing reports that the client accepts.
I'm glad you keep saying certified inspection engineers, because that's one of the elephants in the room in the current American Part 107 industry, where every man and his dog is buying that Phantom 4 professional and offering inspections of roofs, this, that, and the other. As a layman, we're not actually qualified to do that, are we? We can't say, oh, that looks like this or looks like that, because we haven't got a clue. So what is the requirement or what qualification is required to actually be able to sign off a visual inspection?
Yeah, it depends where you are in the world. So in the US, for example, it's like an American Society of Mechanical Engineers, so an ASME certified inspector. I think in the UK, North Sea, it's CSWIP, which I can never remember what that acronym stands for, but it's a body that you have to go and get instructed and pass a test and a bunch of things, and it's like it's formalized in industry. And here I told you at the very beginning about our history in the North Sea and kind of targeting that market to build the business in a kind of sound way, but going offshore has a bunch of other things that need to be done as well. So you need to be medically certified, you need to be ditched into a swimming pool in a helicopter, and there's all of these things that our inspectors were the guys hanging on ropes for decades before they started just sitting very comfortably on the side of the deck, controlling the drone camera with a Xbox controller kind of thing. And those guys are they are qualified, and they have all the qualifications necessary to do the work. If you're doing other industries outside of oil and gas, it's probably perhaps lighter qualifications needed, because you don't need to be ditching a helicopter in the sea and things like that. But yeah, it's all pretty existing.
But at the end of the day, if I were to be starting some sort of drone inspection business, it would probably behoove me to find some qualified people and lock them up in the room with the images and have pilots fly and gather the data. It's two separate sort of entities, really, the inspection part and the flying part.
That's a really interesting point. Yeah, well, I think one of the things is, because drones are a disruptive technology, drones complement the rope access guys, right? Whether you're on a bridge or a wind turbine, ultimately you have to send somebody up there. So drones are just a smarter way of doing it. So it allows you to, like right here on screen now, we've got this bit of cladding that's come off and is in the corner. And when somebody goes up there, when they shut this thing down, if you stood there, you die, right? Because the radiation from that flare. So you have to shut this thing down. And when you go up there, that is the first time you would have seen that. And you wouldn't be prepared for it. You wouldn't have the sacking to bring it back down.
Right.
You just wouldn't be prepared, right? There's another thing down here on the floor as well. Now, all of that stuff, when you go up there, if you're prepared for it, then you get through the work quicker and safer and more efficiently. Now, drones, in that respect, drones really complement the manual access engineering work that goes on. But at the same time, drones can do the general visual inspection a lot quicker, and in some respects it might reduce the amount of work that people have to do, because there's fewer unknowns, basically, which sharpens your toolbox, right? And in that respect, it's a perfect tool for inspection engineers to adopt. Drones are a very good complementary tool, and that's why we sell the software. We don't want to do everybody's drone flying. And then the other part of what you said was, do you want to have a guy flying the drone and then have somebody locked in a room looking at the data? And that's not how Sky Futures do it. We send a pilot and an inspection engineer to the job. And I believe that's what a lot of our kind of contemporaries in the drone inspection market do as well. And then we use, as you can see on this video here, we use a kind of a high optical zoom video camera, and that gives you a very organic way of getting into the detail of structures. You can see here in the image, right? You're getting down. You can see nuts and bolts. If I just pause there in a bit of a blurry moment, and you can use stills cameras as well to do that kind of stuff. That often, whether they have the zoom on or not, I'm not sure, but that's how we do it. So that we have an inspection engineer standing there controlling the camera, getting down into the detail, doing what they would have done hanging on a rope.
So, all right then. So when I start my super duper inspection company, I need to be training the rope access guys because they know. And the inspection guys, the rope access guys can probably do the flying because they're going to go up there and fix whatever needs fixing, so they need to know the way of ingress, and the inspector needs to be in the loop there because he knows what he needs to be inspecting. Well, so it's good to have those two people on site and seen. So I need to
so actually we use a pilot who is a pilot, and then the inspection engineer is the traditional kind of rope access inspection person. So those are the two people, and it's the pilot who is not necessarily up to speed with all of the engineering matters of the structure, and that's the thing. So that is an opportunity for these Part 107 people. They do team up with.
Do you offer? Sorry, go on. Do you offer training for those pilots then? Because that's another skill set, isn't it?
Yeah, we offer both actually. So we've got a training academy in the UK and one in Houston, and we offer a training package for the pilot, and that's like a 4-week training course where you learn all kinds of different scenarios, how to fly different structures in the industrial sectors and things like that. And then in parallel to that, we offer a 1-week payload operator training, and that's for somebody who is a qualified inspection engineer, because all they do ultimately is control the camera, and they need to learn to communicate with the pilot to do a kind of a safe, structured flight.
And did you base it in Houston so you could ring them up and tell them you've got a problem?
Exactly. Yeah. Exactly.
Yeah. I think that's what I'd do it. That's what I'd do it.
Yeah.
So I've been jumping around a bit. So can you show us again how the end report? Is it possible to show us the web end report and the PDF? A sort of an idea of the PDF that the client
exactly right. So this is what the client gets. So they log into expanse.skyfutures.com, and you can have this login actually, demo engineer at skyfutures.com and then demo_engineer. And when you log in, so you now work for this. You're now an employee of this company called Anonymous Oil and Gas PLC. And the inspection company that did your work for you was called Sky Futures. But if it was somebody else, right, if it was like Oceaneering or somebody like that who may license the software, then it would say that inspection company's name there. And we just
branded in their way,
exactly. And we just have a little powered by Sky Futures at the bottom. And then they click on their facility. So there's 3 ways to see the data. This is the first. So this is an asset-centric view that looks at all the data ever, which in the future will be the most powerful view, because this is where you start to do analysis and trending and things like that, and people will begin to forget about doing inspections, right? Like we used to spend all day washing our laundry, now we just stick it in the machine kind of thing. Like this is one view on the data. Another is on a web page. So if I go and look for whichever job it was it number 36? No, 38, that one. So it's one of the reports that was present on that particular facility was this one. So this is now a subset of that stuff we saw in the 3D environment. Is one report done on a particular date for a client, and it's a list of problems that was discovered, and I can get all of them on the page. That's everything from the report, and I can watch videos at the top. I can drill down into any one particular problem and see more details. So I can see some corrosion there on a handrail. It's evidenced by 1 picture, 2 pictures, a video clip as I'm flying past. Also a 2D schematic kind of showing where the thing is, and that's the second way of getting to the report content. The third way is the PDF report. So when I click on, and this is what's nice, like there is no actual PDF report. It gets generated when you click this button. So some clients, like if you're working your way down a bridge, for example, or up a pylon or a wind turbine or something, you give your findings in sequential order of where they were discovered. But you might want to sort them by severity instead. So rather than by, alphanumerically by location. So, like the 1 meter mark, the 2 meter mark, the 3 meter mark, you might say, well, actually give it me from high to low instead. And we do the same thing with the report. So you order it by whatever you want, and then that's it. You just have to wait now for a fairly heavy PDF report to get generated, full of however many high res images that there are. It also includes hyperlinks back to the videos as well. But of course, you would need to log in to see them because this is all sensitive information.
Sure. And when something's fixed, how is that shown in the system?
Right now, it's not. Yeah, so it it maps the old asset inspection process, which is effectively inspection was something that was so kind of periodic, once or twice per year. It just naturally fits the contracting model. So everybody just contracts out. So there's full-time inspection companies, and then there's the operators who are there all the year round. And the inspectors come in during the shutdown period, effectively, on whether a ship's in a dock or a bridge has been closed to traffic, or a wind turbine's had its turbine blade stopped. It all kind of fits the same model. And they would produce this report, and then next year, whoever bidded the lowest or had the best reputation, or whoever scored highly in the tendering process, would send you another report that would hopefully look something like last year's. And that's unfortunately that is truly the state of the market, and that's where drones and a good, solid, kind of versatile data system will help hopefully change that. But as yet, we haven't connected it up to have updates. But the idea being that in the 3D environment, you would get what is the status of this now. And rather than being bright red, might be bright red with a tick in it, or pink, or just however you want to visually indicate it. It will be something that's now resolved. Yes,
because I can imagine if I'm the boss of Big Oil PLC or whatever it was, I can see this model rotating on a screen behind me in my office, and I can see things going from red to green to blue or whatever. Almost in real time as things are happening on my oil rig, because you could have other things happening on there, couldn't you? Oh, here comes the helicopter. It can be quite groovy. The helicopter arrives. So I'd know from a health and safety point of view. So I know the helicopter's there. I know my crews are turning around. I could know where I could populate it with people. I'd try and know where the crew are for event of emergency or disaster. You can imagine you could do all sorts of. Maybe it's too Star Trek or Star Wars.
No. It's the Internet of Things. It's the Internet of Things, exactly. And it's and this is where we're kind of we're pretty ambitious in what we're doing, but we're also modest. And there's I don't think anybody's going to own that whole thing. In the Internet of Things, there's going to be lots of different secure web services that are all pulled together in a way that communicates. And you would be able to achieve what you're saying. So you would see the aviation information. You'd see if it's offshore like this, or pipelines, or cross ocean telecom networks or whatever. You'd see kind of ROVs under the sea checking them out, and all manner of things. And it'd be great.
Pull back, see the shipping and all that sort of thing. And you could pull the data for the AIS for the shipping from, or ADSB for the aircraft. You could pull that in from all sorts of other services and drop it onto your map. And that's sort of I'm going to jump. I'm not thinking very well about this, but I know one thing you guys do, which I want to talk to you about, is you go all the way in. You do internal inspections of things as well.
Oh yeah, that's right.
With a quad that can fly, inside tanks, isn't it? I think.
Yeah, that's right. Yeah, so we use Flyability's Helios drone. Yeah, so if I take you to where am I? So if I take you to the home page of this site, I actually have a demo. Version of one of our reports up here. So our client lets us show this data. So for a floating production storage offloading vehicle, right? So this is a ship that kind of produces oil, stores it, and then offloads it to another ship or a pipeline or something like that. And this could be a storage tank. We ourselves have done water tanks, gas storage tanks, furnaces, the internals of ships, the ballast tanks of ships, things like that. This is the first job we ever did, which was sometime last year in 2016. And this is it. So if I take you through to, if I just click on one of those, as you've seen, it kind of takes you through to something that, it's pretty magical really for the business, to this 3D environment contextualizing the problem that's just been found, because going inside tanks is inherently very dangerous. And, tens of people die every year doing it for all manner of reasons, because of asphyxiation, and people, tanks get filled, people get locked in, there's explosions because they're dangerous environments, all kinds of things, right? They're just very uncomfortable places to be. So you got these poor inspection engineers, and they are doing their job of trying to work out how corroded is this surface, and making notes, and whilst effectively doing the krypton factor, trying to climb through ballast tanks of ships, and it's pretty dangerous activity. And Flyability have ingeniously come up with this pretty unique drone, which has a protective cage that is able to rotate around all three axes. It's called the Helios, and it's impact resistant up to about 15 kilometers per hour. And they've been fantastic with us. So we approached them to start using this at our kind of testing and training center to see if we could apply it to internal tank inspections, because it's a huge market, it's incredibly dangerous, and drone data is excellent for it. You know, like being able to go back and look at this weld seam on this corrugated bulkhead here is fantastic, because typically nobody in the company that owns this ship has ever seen that firsthand. Only some third-party contractors, and that knowledge departs when the contract ends. You know, that's fairly typical for how these things work. And it takes really high-res images with its onboard payload, and with our software, you can move your way through the range of media like really intuitively once the inspection engineer has located it all within the 3D environment. And you know, you kind of work your way around, and you can look at the critical bits, get up underneath welds, brackets and welds and things like that, and see what's going on. So
will you be building 3D models based on these images, point cloud models based on the stuff that, so that you could then freely move around inside that 3D model, as it were, with VR goggles or something like that?
Yeah, I mean, however, we can do that. Yeah, for sure. We've kind of built a system internally which you load enough images in and it'll build you a point cloud kind of thing. We tend to find for vertical structures and for complex geometrical spaces, it's not high resolution enough. But if you're just trying to get the gist, if you're trying to get the gist of where you are, then it's great, right? So we have kind of like you know, some buildings, and it kind of looks like it's snowed on the roof a little bit, but it's great. Yeah. You know east from west, north from south, and you know roughly what tile you're talking about, or whatever. In terms of doing that with the Helios, I'd probably have to speak to the Flyability guys and our image analysis guys, because obviously in the photogrammetry calculations, if the cage is in the way a lot of the time, that might interrupt the photogrammetry calcs, because it's going to keep seeing, you know, line continuations and mess that up. But I don't want to kind of say that on Flyability's behalf. That's just my professional guess as to whether Flyability imagery would help make a photogrammetry point cloud.
Yes. Well, funnily, just today, a Kickstarter, or it's actually Indiegogo, has come out, and somebody is claiming to have invented the very first such flying machine as this. And it's on Indiegogo today. It's a complete rip-off of this.
Wow, really?
England as well.
Wow.
Now, I haven't bothered putting it up because of the wild claims being made.
Wow. Well, I'm sure they've got
there we are.
Things. Hopefully they're protected. Yeah. So yeah, but it's a fantastic tool. We're doing great business with it, and it's an absolute no-brainer in terms of health and safety, and you know, high-quality data capture that was just. You know, you can always shut down and send a person somewhere, even if it is on a rope somewhere on a bridge. That's pretty dangerous, but it's a well-established market. But sending people into confined spaces is notoriously treacherous. And
yes, so they're going to have super extra special skills and tickets, and that's going to make that person very expensive, isn't it?
Yeah, exactly. And there's, you know, depending on where you are in the world and your safety regulations, there is a demand, you know, particularly in the EU and the UK, for adopting inherently safer practices. So you in some way obliged to even consider this. That's the way we look at it.
Okay. Well, and I mentioned cost then. So this all looks great. Well, what's it now? Here I am with my super duper new inspection company and all these people lined up ready to work. What's it going to cost me to
use Expanse? Yeah, you can actually just go on our website and see. So it's $550 a month. So I go to skyfutures.com. So the product is called Expanse. We'll go here and then. Right. Oh, could I wait till?
Oh, I like Falcon 8s. I like them a lot.
Good. Yeah, we do. Prices. So the product is called Expanse, and it's $550 a month, and that's for you know, you can have as many if you're an inspector, you can have as many client companies as you want and do as many reports as you want and have as many viewers of that data in your client office as you like. But we do kind of scale the cost with how much data you're using, kind of thing. But it's 100 gig. But then you buy. So this is, what does that work out as? I think $7,000 a year, something like that, $6,500 a year. And that then goes up to 200 gig if you pay another $500 a year. So for another $50 a month, you double that, and then for another $50 a month, you triple it, kind of thing. So it's not really there. The data limit's not there really to penalise people. It's just effectively we want people putting data in the system.
And what's 100 gig mean? Is that a lot of data if I've got an oil rig? Is that one oil rig? Is that 10 oil rigs?
Yeah, we tend to find one job on an oil rig, and not forgetting that with oil rigs, people still buy inspections once per year because there is this element of people are. It's like we have drones, but people are using them like they would use rope access workers. Effectively, they're just bringing them out once a year. But the market's changing. Yeah. People will have them on board full time soon, I'm sure. But that's one campaign, which typically you go out and you do 5 structures. So you do maybe a derrick, a flare tower, a leg, the caissons, a comms tower, something like that, and that will produce about 10 gig of data. So that's about that's like a big job per month. If you're doing those kinds of big jobs, if you're doing smaller jobs like a cell tower, things like that, then it's obviously some multiple of that.
Cell towers are pretty popular. People seem to be diving after that. We didn't discuss looking at those, but would you have any examples of that sort of thing you could show?
I don't have any that's publicly available, so I don't have any in the demo accounts or anything like that, unfortunately. But they're I think it's a big market. I think there's hundreds of thousands of them around the world. So it's there's
and how you must be. Your R&D department must be looking at the drone-in-a-box solution. You've mentioned it a couple of times now, and it's a no-brainer, isn't it? It'll have Intel RealSense, so it doesn't hit the oil rig. It'll have its own little weather station, so it knows it's not raining or too windy, and it'll go off and do its autumn and visually it's good enough. It's not foggy, so it'll go off and it'll trawl around the oil rig all by itself, and then it'll get this data back somewhere. You must be thinking about that. How would that somewhere work, and how would those licensing work? We probably haven't thought about this, but that's obviously got to be the next leap. Yeah,
for sure. Yeah, I mean it is something where we consider ourselves kind of drone agnostic, but we are definitely fans of certain drones because they, like you said, the F8 is great. It's especially good in high hazard industries because it's got GPS redundancy and propeller redundancy and a bunch of other factors that are fantastic. But there's lots of other drones that we'd consider too. In terms of drone in the box, there's a number of different vendors out there that are doing really good work, and we're talking to several of them. We can spin off instances of this product so that it sits in-house. It's just that's pretty straightforward these days with web applications. You just kind of make a Docker instance and give them their own copy running on the server, and we'd have a license price for that. We're not big fans of that because then you're not obviously contributing to the general kind of global classification training of our artificial intelligence, which is a bit of a shame. But if it brings in license revenue, we'll do it. We are only 5-6 years old as a company, so you don't say no to money, kind of thing. But it's not too dissimilar from the kind of industry that we cut our teeth on, which is out on an oil rig. You don't have a very robust internet connection, for uploading 10 12 gig of video data.
That's what I was thinking. That's exactly what I was thinking about. Yes. Yeah.
So you kind of fly back with an SD card in your pocket, or actually two guys, two people have it in their pockets because you don't want to just lose one of them, and you just kind of work on it when you get home, kind of thing, to build the report. But in the future, as you say, you do need it somehow connected to the Internet of Things. But I think companies are wising up to that. It's when times are bad, you probably want to increase your bandwidth, not decrease your bandwidth to save cost, because you do get kind of a business benefits from having better data communication and things.
Yes, force multiplier and all those other good words that people use. No, it's amazing. So have you got anything else that you want to show me on this?
No, I mean I could kind of show you some of our Harry Potter stuff, but maybe I'll save that for another time once it's more commercial and not vaporware, because we don't like to sell that stuff.
You can't be in the unmanned aviation business. You're supposed to sell the vaporware, not the stuff that actually works.
Exactly. No. I get too many distracting calls about stuff we don't have yet, so it's like I'll concentrate on getting this sold first and get people using it.
So you've got offices around the world, primarily, and Houston is I'm guessing that's kind of an oil capital of America, is it? And that's probably why you're there.
Yeah, it's a bit of a hub just from our traditional. Yeah, so we're in Aberdeen, Abu Dhabi, Kuala Lumpur, Houston, and then our head office is in London, just near Heathrow Airport. Yeah.
Right. Okay. And people can go to Sky Futures untitled.com to find out more. I'll put the link, if you don't mind, I will pull that login that you used earlier on and put that in the comments below, so people can log in and have a play with it themselves and see what they make of it. And then should we be sending them straight to you or just via the inquiry email address?
Just the inquiry email address is great. Yeah, that comes straight to me anyway, so that's great.
Well, that's perfect. Well, thanks very much indeed, Colin, for taking me through this. It's fascinating, and it is really the real work. As you said earlier, the data's king, isn't it? It's all about making actionable data. Getting that data now is relatively easy. We've gone beyond the days where keeping the things upright and pointed in the right direction was hard, and the hard part now is creating actionable data and then earning some money off it yourself to pay for all the software and things. So that's fantastic. Thanks very much, and please come back soon with the Harry Potter stuff. I'm very interested in that.
Great. Thanks a lot, Gary.
All right. Thanks very much, Colin.